let's get some practice with graphing these. Again, I'm going to try to think of them as these kind of separate functions, but then having them all together as a single function. So with this first one, we can start by just actually finding a few coordinates. It's like this f of -3. Well, if I'm plugging in x equals -3, I want to figure out which domain that fits, and that's going to be this first one, where x is less than or equal to 1. So what we'll have is -3 cubed, which is -27. So we have this coordinate, -3, -27. For f of 7, I think x equals 7 will fit in this third function, where x is more than or equal to 4. So we would have 6 minus our input of 7, which is -1. So that can be nice to have a few coordinates so that when you're graphing, can match up. Alright, x cubed. So what I could do is, with everything in our class, that I'm sure I've said in almost every single video, find the method that works for you. There's a few ways to approach this. Maybe you can visualize how these piece all together at the same time, and awesome, go for it. What I'm going to do is going to be similar to what I did in that last video, where I just kind of end up graphing the whole function. Then once I see it, then I limit the domain. So what I mean by that is I'm going to look at x cubed. So if I just wanted to graph x cubed here, so I'd have my cubic function, and I could grab those key points that I thought about when working with our graph transformations. So with that, and I'm just going to use kind of a dotted line here, that then I can get some key points for making my graph. But then what I'm going to do is look at my domain. So I want that graph if x is less than or equal to 1. So what I'm going to do is go to where we're limiting ourselves. We're stopping at 1, and it's going to equal at 1. So I'm going to have a solid dot there. So at x equals +1, we have this output of +1. Then I want that graph for every value of x that's smaller than that, which means I'm going to have all of this to the left-hand side that I'm graphing in blue here. So that right there is part of my piecewise function up until x equals +1, and then everything that's to the right of +1, I'm going to erase away. And then I move on to my next piece. I'll graph this next piece in red here. So my square root of x, and I could start graphing this over. Actually, if I started graphing on top, it would actually land on top of itself, and then out at 4 I have 2, out at 9 I have 3. So I can start to visualize my square root function. And starting at x equals 1, but not including it. So I'm going to look at x equals 1, but I'm going to use an open circle, which, if I look at x equals 1, and I'm taking the square root of x equals 1, I'd actually land on top here. So I'd technically have an open circle there. However, my function's already defined there. So if my function wasn't already there, I would draw that open circle. But it's kind of redundant to have both the open circle and the closed circle, because it just means we're defined there. So with that, I'm not actually going to draw an open circle there. I'm going to keep that closed circle from my first function. And then we're going to graph until we get to x equals 4. And at 4, I'm going to have an open circle because we're not equaling 4 there. So what I'll have is starting at 1, 1, and then going off to 4, 2, but we'll have an open circle at 4, 2. So what I'm going to do is just connect those, the kind of curve that we would have from our square root of x. And then I just erase everything else. Alright, so I can see my x cubed, and then I have my square root of x over that little interval from 1 to 4. And now, and I'll do this part in green, we're going to have our line 6 minus x. So we'll have this line with an intercept at +6 and a slope of -1. And this will be starting at x equals 4, so we'll have a solid dot there. So what we could do is visualize our line. Let's see, intercept of 6, and then a slope of -1. So something like that. But our function is starting at x equals 4, and we'll have a solid circle there. So what's going to happen is our line goes through this point 4, 2. So where it wasn't defined before, it is defined now. So we're going to have a solid circle at 4, 2. And then we'll follow our line with a slope of -1. And then we just want to erase anything else up there, because that's where we could see it wouldn't be a function if we had all those pieces up there. But now we have a function. We have something that would pass the vertical line test. We see x cubed for all x values less than or equal to 1. We see our square root of x between those between 1 and 4. And then for 4 and above, we see our line with a negative slope of 1. All right. Let's look at one where we're given the function and we're actually going to find it. So, domain of the function. So if I'm kind of walking along this x-axis here and seeing where my function is defined, we're good, good. At -2, it's defined because we have that solid circle down there. At +3, we have a little hole occurring, because it's not defined up above, it's also not defined below, and then it's defined until +7. So we're going to need a domain that describes this idea that we're defined from -infinity up until 3, and then 3 to 7. So I'll have -infinity to 3, and then use parentheses to show we're not including 3. And then parentheses 3, so we're starting at 3 but not including it, and off to 7, where we'll have a square bracket because we are defined at +7. Alright, and then for range, we'll have everything from -infinity, since our line's continuing on down, and then we're defined. And at 2 we're good because we're defined on that line. And then we'll get to +3, but we're not defined at +3. So for range, we'll have everything from -infinity up until 3, but not including 3. All right. Evaluating functions. So g of 6 is where x is equal to 6, and we want to find our function output, which is up here at +2. So we have that coordinate 6, 2. Solving, we're saying our output is -5, so this is where we can imagine a horizontal line at -5, and we want to find all of the spots where our function intersects. So we're going to have x equals -4, and also x equals +2. All right, so now to make our function. So we want to make our function g of x. What I can see is our piecewise function is made up of 3 pieces. And what I'm going to do is start with this first piece here. So I'm going to use slope-intercept form for these. So my slope, all you need to find slope is basically 2 points, and it's the change in y over change in x. And what I can see is for y we moved up 1, and for x we moved to the right 2. So my slope is going to be 1 over 2. And then to find the y-intercept, what I want to do is just imagine continuing the line on until I intersect the x-axis, which would be there at -3. So that's one of my functions, is the 1/2 x minus 3. My next line, I can see my y-intercept at -1, and then the slope, we would go down 2 over 1, right 1, so +1. So this is going to be a slope of negative 2 over positive 1. So we'll have a slope of negative 2x, and then y-intercept of minus 1. And then this third line is just the constant, where the output is always positive 2. So there are my three functions. Negative 2x minus 1, and just positive 2. Now I need to restrict the domains. So for this first function, what I can notice is it's stopping at negative 2, and we have equality at negative 2. So I want to see this line for every value starting at negative 2 and smaller. So I'm going to say that's true if x is less than or equal to negative 2. Then for our second function, starting at negative 2 but not including it, and then we see this function up until positive 3 but not including positive 3. So this function is negative 2 is less than x. And we won't have the equals there because we have the open circles, and then less than 3. And then our last piece starts at positive 3, but isn't defined there, and goes until positive 7 and is defined there. So we'll see this from 3 is less than x is less than or equal to 7. So that's how we can read the graphs as well as draw them.